Hi, today we're going to go over lessons 6.2 and 6.3 over parallelograms. So let's start with defining what a parallelogram even is. Now, first of all, it is a four-sided figure, so this is called a quadrilateral, where both pairs of opposite sides are parallel. Now, once you have a parallelogram, there's lots of properties that are true. So make sure you fill these in. These are important. You'll need to know them to complete all the problems within this lesson. So the properties of a parallelogram. If the four-sided figure, if the quadrilateral is a parallelogram, then these things are always true. First of all, the opposite sides are congruent. Okay, this is always true. Also, opposite angles are always congruent. We know that consecutive angles are supplementary, so that means they equal 180. And we know that the diagonals bisect each other. Okay, so we're going to take this information and we're going to try to apply it to these problems. So, according to the rule that says opposite sides are equal, we know these are equal. Now, they're asking on this question for us to find the angles. So we need to find angle 1, angle 2, and 3. So opposite angles are equal. So if angle 1 is 1/12, across from it is angle 2. So we know angle 2 is also 112 degrees. So to find angle 1 and 3, we're going to use the rule that's right here above. This is consecutive angles are supplementary. So that means two angles side by side like this. They're going to add up to give you 180 degrees. Okay, so let's take 180, subtract 112, and so I believe that is 68. So if angle 3 is 68, I know opposite angles are equal, so angle 1 over here is also 68 degrees. Okay, now looking at part B here, I see a linear pair. So we know from chapter 1, linear pair angles have a sum of 180. So to get angle 2, I'm just going to take 180 minus 75 to get 105. And this is angle 2. All right, so we need a plan on how to get angle 1 and angle 3. Now, let's keep in mind opposite sides are equal and parallel. That may help us. Now, I see I have parallel lines, and this is my transversal. And actually, I want to do this the other way. 1 second. Let's make our parallel lines go up and down. And this could be my transversal. So, angle 1 and angle 3, I can prove that they're equal because they're both alternate interior angles. Now, we have to still figure it out. But we know we're a step closer. We know angle 1 and angle 3 will be the same measurement. Okay, now I see verticals here in the middle, so I know this angle is 75 degrees. Now, if we look only at this triangle, we know triangles have a sum of 180 degrees. So let's just subtract away the two angles that are inside this little green triangle. So first let's subtract the 75 to get 105. And then I'm going to subtract away the 50. And I'm doing this today without a calculator. So, of course, you could just do it on a calculator. And so I get 55 degrees. And so if angle 3 is 55, I know angle 1 is also 55. Okay, and so it's nice to always just go ahead and write out my answers. Good. Okay, so let's find the third one, part C. Now, it's kind of hard to tell what this information is. 2h is going to this line. H plus 5 is going to this line. Okay, so we have a rule. Let's go back and look. It says diagonals bisect each other. Okay, so what that means is that these two segments are equal and these two are equal. So there's a distractor. There's extra information here. We don't need it all. So obviously, the 2h and the h plus 5 are the two equal parts. So I'm just going to set those two equal to each other. Let me back this up. 2h is equal to h plus 5, and let's subtract h from both sides. So I'm left with h equals 5. Okay, and the directions just say find the value of the variable. You don't have to plug it back in. If you're good, you're finished. H is 5. All right, letter D. Now we have to, again, apply the rules that are given to us up at the top. Now let's use this first rule here that says opposite sides are congruent. And we know that the left and right side will be congruent and the top and bottom will be congruent. And so again, there's extra information here. It's a little trick of a math class to give you extra information to make you kind of look through it and figure it out. The top and bottom are the two parts we're going to use for this problem. And so let's just solve. Let's subtract 14.5 from both sides. So when I do that, I get 6. And you're finished. Okay, for the next one, I'm going to plug the information into the picture. So A to E is 3x, E to C is y, D to E is 4x, and E to B is y plus 1. Okay, so diagonals, we're back here to this fourth rule. Diagonals bisect each other. Okay, so what does that mean? That means when you draw the line from B to D, E is cutting it in half. So we know these two are equal and these two are equal. Now, guys, I know it's going to look weird. We're able to solve this. Just hang on. It'll be fine. 4x equals y plus 1 is the first equation. And going the opposite direction, we have 3x equals y. Now, this is a form of a problem called systems of equations, and this one's really not a difficult one. We need to eliminate either the x values or the y values. And so what I can do is I can do a substitution. And so for this y right here, I'm going to say, what is y really equal to? Well, y is really equal to 3x. So let's take out y and replace it with 3x. So when I do that, I have 3x. Let's take out the y and put it in its place. And now I have an equation with all x's, and I'm able to solve now. So I'm going to subtract 3x, and I just get plain x equals 1. Now we're not finished because we only know x. How do I find y? Okay, we're just going to plug it back in. So, you pick one. I'm just going to pick the bottom equation here. So 3 times 1 equals y. So 3 equals y. So there's my two values, x and y. Okay, so that was it for lesson 2. Now, lesson 3 is going to start with 6 rules. Now, these 6 rules, I really, really stress so much that we're going to do them every day. And if you get these 6 rules, you're going to understand pretty much the rest of the chapter. So with this first one, this is just the definition. And it says both pairs of opposite sides are parallel. So opposite sides are parallel. So make sure you put this on your picture. You fill in this blank. You're going to end up knowing these forwards and backwards. And actually, you're going to end up knowing them by the number as well. All right, number 2. The opposite sides are congruent. So let's go ahead and mark opposite sides are congruent. So you have 2 things about sides. The sides are opposite or equal, and the sides opposite are parallel. Now the next, we have 2 things about angles. Both pairs of opposite angles are congruent. So opposite angles over here are equal. And number 4 is adjacent angles are supplementary. So the angles right next to each other add up to 180. So far you have 2 about sides, 2 about angles. Now we have 1 about what happens in the middle when these lines cross. These lines are called diagonals, and they're going to bisect each other. So what that means is that you have equal parts. So we have, look at my pen, we have AE is equal to EC, and we have BE is equal to ED. So again, 2 about sides, 2 about angles, 1 that crosses in the middle. And I usually call this one the buddy system. This one, it says 1 pair of opposite sides are both, keyword both, parallel and congruent. So the same side has to have parallel and congruent. Like they're buddies. They have to be together. You do not want to split them apart. Now, of course, it can be rotated so the left and right have the 2 parts. Now, I'm going to draw this incorrectly, and this is how they usually try to fool you. They draw you a parallelogram. Just excuse my picture, you know what I mean. And they put parallel sides going one way, and they put the congruent sides going the other way. So when you see this picture, this is a trick. Do not fall for the trick. This is false. It does not work. It is not a way to prove that it is a quadrilateral. Okay, so we're going to go through these. And yes, I did put the number. If you want to put the number, you can. If you want to write it out. Now, this one is the buddy system. Notice they're together. This was rule number 6. And do you have to remember all the numbers? And you don't. You can write them out. Over the years, kids have found it easier to memorize them by the number. But it's totally up to you. Okay, next one. What happens in the middle? Diagonals bisect. Well, this is rule number 5. So let's go back and look at it. That one is diagonals bisect. Okay, letter C. Now, you just have to kind of add. When you add these together, you get 180. When you add the other direction, you get 180. So adjacent angles are supplementary. So let's see what rule number that is. That is rule number 4. So yes, I had that correct. Good. For letter D, this is a trick. This is not a parallelogram. Notice they split apart the buddies. They have to be on the same side together. Okay, so letter E is also a tricky one. So here's the situation. This one you need to pay close attention to. We know these angles, but we don't necessarily know these 2 green angles. Or do you? We had a rule a while ago called the third angle theorem. And so when you have a triangle and you know 2 angles within the triangle, you can assume that the third angle is congruent to the third angle of the other triangle. So here's what I'm saying. So let's call this angle 1 and angle 2. Angle 1 and angle 2 are the same. Angle 3 and angle 4 are the same. So since they both have 2 angles in common, that means that the last angle, the green angle, also has to be in common. So because of that, we can say opposite angles are congruent, and this is rule number 3. Let's go back and look at it. And it says both pairs of opposite angles are congruent. Okay, so the last one, F. This one is just opposite sides are congruent. And this is rule number 2. What additional information would you need to prove that the quadrilateral is a parallelogram? Okay, so there's not enough information on this. What we're going to do is we're going to try to figure out what else we need to know. Now, we know that these two sides are equal. Now, we have a couple rules that talk about equal sides. Now, to be clear, we know rule number 2. This is opposite sides are equal. And we also know rule number 6, where you have one pair of equal sides and you have one pair of parallel sides. So technically, you could pick either one. And we're just going to give you what additional information you would need. So when I did mine, I said I needed rule number 2, which is opposite sides are congruent. So I would need to make AD and BC congruent to each other. Okay, so on the next one, again, you just have to read this given information, put into the picture, and these are diagonals. There's only one rule that talks about diagonals, and it says diagonals bisect. So I need to put that these two pieces, AE and EC, are congruent, and this is rule number 5. Okay, for C, this is your two angles are equal to 180, and this is angle D and A. So this is on the left side. So we knew these. So you had a choice. You could either add, and I'll do them in blue, I could either do the top or the bottom because they're both adjacent to A and D. Now, you just pick one. You want to add the two top angles or the two bottom angles. I just chose the top. So I chose angle A and angle B equal 180. And this is rule number 4. Okay, it says what value of the variables would make each quadrilateral a parallelogram? Okay, so you're solving again. Now, you're going to apply all those 6 rules that you know. You know, first of all, opposite sides are congruent. So the left and right's congruent. And the top and bottom are congruent. Okay, so I wrote them out here. Now, I think the easiest one to solve for, to me, would be the left and right because the top and bottom has an x and a y value. So let's definitely solve for x first. Take 3x and set it equal to 6 and get 2. Now, once I know x is 2, look up here between A and B what I did. I just plugged it in. So instead of 2, I plugged it in for the x. So 2 plus 2 is 4. So now I know that 4, the top, is equal to the bottom, which is y plus 1. So let's add y over, or let's add 1 over to the other side and get y is 5. Okay, let's see what rules we can apply on this one. So to solve, yes, opposite angles are equal, but if you look at these two, you would have an x and a y value, and that's not really very helpful with solving for a variable. So what I did is I added these two together because we know adjacent angles are supplementary. So I said 105 plus 5x equals 180. So I subtracted 105 to get 75 and then divided by 15 to get 5. So how do I get y? Okay, a couple ways. I could either plug it back in and then do opposite angles are congruent, or I know, let's get a pen, I know these two together have to equal 180. So I could just take 180 minus 105 is 75 and get y. Okay, for letter C, I know diagonals bisect, and it looks like my pen was off a little bit. I was trying to show that these are congruent. So, and I'm not able to erase it. Okay. So, diagonals the diagonals bisect. So, let's just remark this up. I know these two are congruent, and I know that these two segments are congruent. Okay, now going from P to R, this is true. Y does equal x minus 5. But are you able to solve for x over y? And of course you can't. So let's go the other direction. And so I said 6x is equal to 72. So when I divide by 6, I get 12. So once I get the 12, I can go back up here and say, oh, x is really 12. So 12 minus 5 is 7. So that's how I get my 7. All right. And this looks like that was all your problems to do. So we might be done. Okay. So if you guys have any questions, please feel free to contact me, come to tutorial, send me a message. Thanks.